Alright, so we gotta look at molecular orbitals, like what the orbitals look like when atoms are combining, when they make bonds. So molecular orbitals are orbitals that apply to the entire molecule. They when you make a bond, right, it's two electrons that are being shared by each atom. So that bond is going to be called a bonding orbital, and when two of those atomic orbitals combine to make an orbital that's being shared, it's symmetrical around the axis that's containing the two atomic nuclei, and what is called a sigma bond forms. And a sigma bond is a bond that has end-to-end overlap. And what I mean by that is like this. So if we have two s orbitals that are coming together because those electrons are the ones that are going to be shared, it goes from being two spherical orbitals like that to being sort of an elongated oval-shaped type of orbital, and that would be sigma bonding. Now it's an orbital that's shared by both atoms. When two fluorine atoms combine, the p orbitals are going to overlap end to end. So when you have p orbitals that have a sigma bond, it's going to look like this. Now this is kind of jank looking, but these two come together and they have end-to-end overlap, and then they end up making this right here. So that's what it would look like if you have a p orbital overlap. That's end-to-end. Now there's also pi bonding. Pi bonding is side to side. Now obviously this cannot happen with s orbitals. It can only happen with p. But with the p orbitals, you have, the different things. You got, the one going front to back and all. You got all these. So if you're coming in side to side, you're only going to have one that would be end to end. The other ones are actually going to end up being side to side, and that's where we get a pi bond. Pi bonds are the side to side. So when the atoms come together like this, then you're going to end up with it kind of morphing in the top and bottom and then kind of disappearing down here. So that would be a pi bond. All single bonds are sigma bonds. So anytime you have a single bond between atoms, that is a sigma bond. Every time you have a double or triple bond, though, the additional bond beyond the first one is a pi bond. So a double bond has one sigma bond and one pi bond. A triple bond has one sigma bond and two pi bonds. So, that's just what happens. So double and triple bonds are obviously going to be stronger and shorter because you have more overlap. Alright, so now we got hybrid orbitals. And the only instance where we're going to talk about hybridization, does it happen in other places? Sure, but we're only going to talk about it as it pertains to carbon. So when we did carbon, we had the 1s filled up, then we got the 2s, and then we had 2p, and it looked something like this. But when we did the Lewis structure for carbon, it looked like this. Well, those don't match up. You see how we got 4 electrons ready to make a bond, and over here we only have 2? So what actually happens is something called hybridization, and that's where the S and P are actually going to kind of mix. They're going to come together to form this hybrid orbital, and so we're going to have these SP orbitals, and you put 1 in each of them. So now these things would match up. So you're not going to have the S and the P like that. You're just going to have these SP orbitals, and that's how that's going to work. So this is what it would end up looking like, the 2s and the 2p combined. And then you have this sp3 hybridization right there. That's when carbon would make 4 individual bonds. So what's going to happen here, you have 4 bonds that are being made. You're going to have end-to-end overlap in each one. So you got sigma bond, sigma bond, sigma bond, just like that. In some cases, well, this is methane, that's how that works. Some cases, you're not going to have 4 bonds with carbon. Sometimes it only makes 2 or 3 bonds. In those cases, the hybrid orbitals are called sp2 or just sp. And this happens when 1s and 2p orbitals hybridize, or when 1s and 1p orbital hybridizes. So in this case, this is sp2 hybridized. So this is where carbon only makes 3 bonds. And so in this case, watch what happens when we bring them together. Each carbon is going to overlap here, and then these are going to overlap here, like that, and then you're going to get side to side. And remember, these are the same orbital, so this is just one bond, this is one bond, so that would be a double bond between the carbons. Right here would be a triple bond, so these two, top and bottom, that would be one bond, and then these over here would be another bond. This would be your sigma bond, and then your hydrogens would go like that. That would be when carbon has a triple bond. Now, is this confusing or what? There is a very simple way, simple way to do this, and I'm going to tell you the shortcut, because if you don't get this, it doesn't really matter for this class. I just want you to be able to use it. So we have we got three different hybridizations, sp3, sp2, sp. If you're looking at carbon and you want to know how it's hybridized, all you got to do is count the bonds coming from carbon. Now, in this case, I'm counting a triple bond as one bond, I'm counting a double bond as one bond, and a single bond as one bond. So for instance, if carbon is triple bonded, like we just saw, okay, that is one bond here, one bond here. That's 2 bonds for carbon. Give a letter for each bond, sp. All right, that's its hybridization. If carbon has 3 bonds, in this case a double bond up, 2 single bonds out, give a letter for each bond, spp. So sp2 hybridization, and that is correct. If carbon is making 4 bonds, okay, a letter for each bond, 1s and 3 p's, that's 4 letters, 1 for each bond, it's sp3 hybridized. That's the shortcut, that's all you need to know. If you want to figure out how the carbon is hybridized, which is all I'm going to ask of you, just count the bonds, give a letter for each bond, and you got it. All right.